All right. Okay, well, I think this will work, I hope. All right, so if you need to do so, navigate to your folder and you'll do a git pull upstream main, and it should download lecture 2-1, I hope. Okay, and we'll take a look at what this is. I'm gonna go ahead and just, for the sake of this, I'm gonna go ahead and clear my outputs and I will run them as we work through this notebook. But as far as you go, let's see. You can probably just follow along. I hope the audio is working here. All right. Okay, so today we'll take a look at functions in Python. Pretty much everything in any programming language, even like the most complicated game that with beautiful graphics and everything, can just be boiled down to these types of instructions. Sorry, let me pull up this thing. Okay, so all right, and so all the instructions, again, even in like a beautiful, like the latest computer game or whatever, is you get input from a keyboard, a file, network, device, like a gamepad or something like that. And then there's output, data, display data to the screen, save a file, send over a network, something like that, okay? There is math that is being performed. And so in a computer game, the math that is being performed is just, what is the color of this pixel on the screen, right? And if you have a game in 4K, are you here?
Yeah.
Okay, great. Let me just pause this for a second. I just kind of connected to the local PC and whatnot.
Okay.
But let me just show you what's going on here. So if I switch to laptop,
yeah,
this is
sometimes it might be the adapter. So if it's not an Apple adapter, so the system doesn't like it.
The system only works with Apple adapters.
Yeah, I don't know why, but
We'll try it. Yeah. Hey, that's great. Okay.
And then if you want sound.
So do I check this out from?
Yeah, so if I could just take your name.
Okay. Yeah. Mine's Chen, right here. And I'll hold on to this. Okay. I guess I'll work the department now. This adapter is no good. Yeah.
And then what's the class?
This is Stats 21, Lecture 1. Yeah. Okay, I appreciate it. Thank you so much. Okay, so I'll hang on to this. So
wait, actually, maybe your email too.
It's Miles Chen.
Okay.
At stat.ucla.edu. Yeah. Okay. All right. I think this is being recorded. I guess I could. Hopefully, this will this will still work. Okay. So basically, even the most sophisticated game is just really like, what color should this pixel be? And that's a whole bunch of math operations. And inside, to determine what color that pixel should be, you have these kind of mathematical models of like, this is the 3D shape, and when the light reflects off of this and it bounces off of this, and you're tracing the rays and whatever, it's like, this is the color, and it's doing like millions, if not billions of these calculations every second. And when you have a 4K display, you've got a whole bunch of these pixels to calculate, and you're doing 60 frames per second or whatever. It's just a whole bunch of math operating, okay? But really, that's all it is. We're just doing some math, okay? And then there is conditional execution that says check conditions and then run the appropriate code. And then everything, there's repetition, repeat the code, usually with a little bit of variation. If, you go over here, what do you do? And that's basically it. So how everything runs is done via functions. Okay, how are functions executed? Functions we give them a name, and then to call a function and get it to run, we type out the name of the function. We put in a parentheses. So if you just type the name of the function, you are asking Python for the object of the function itself, but you're not asking it to actually do the thing, right? So it's the difference between the word run and actually doing the activity of running, right? To run, okay? So if you want to execute the function, you have to put parentheses there, and that tells Python we actually want to call the function and execute it. You put any kind of argument inside those parentheses, and Python will run that function. And a lot of times, functions will return a value. A function will take the input, do whatever it's supposed to do, and then says, okay, this is the returned result. This is the output. And so here, a very simple function is type, and you give it an object, and the type function will tell you what type of object it is. And so in this case, when I hit type on the number 42, it says, this is an integer, okay? This is an integer. Okay, so again, the difference between calling a function and just asking for what a function is. Here I run it print without a parentheses. This is the object itself, and it will say, this object print is the function print. Here I put print parentheses, and I put quote hello, and that actually calls the function, and now it prints the string hello to the screen. You can print, here I'm going to print a tuple of values 1, 2, and 3, and it outputs those values 1, 2, 3. There's optional arguments in print. One of them is the separator. So what do you do? How is it going to output this? And so here it puts the separator, the dash in between those values 1, 2, 3. You can always ask for help on any kind of function. And so here you can call Control I to get help on something, I think. So here, if I hit Control I while I have print highlighted, it will in JupyterLab it pulls up an additional pane that shows contextual help. You can type help on print, and it will basically put the same output into the notebook itself. So sometimes you just want to see it. And then also you can always, in JupyterLab, you can go to help, and then you can go to the Python reference or whatever it might be, okay? And then, oh yeah, one of those things is show contextual help. So again, in like if you select help over here, you can do click on a function. Is this not working? Okay, I don't know how this works anymore. Okay, my contextual help is broken now. Okay, I don't know what happened. Well, here it goes. There's help. Here's print. Okay, it's working now. Well, of course. All right. And so, if you ask about, okay, so just a little bit about strings and stuff. If you open and close your string with a double quote, you can include single quotes in there, right? So that works. If you open your string with a single quote, you can't put single quotes, like you can't use a single quote for an apostrophe. This will result in an error because it thinks that I can single quote. That's technically the apostrophe and can't, but it closes off the quote, and now it gets confused about the T. So it says that's invalid syntax. If you want to include the single quote and open and close with single quotes, you can do that. You can escape it with a backspace. You can put in double quotes inside here, but now people won't understand what's happening here because that feels weird. So, and then same thing, if you want to open and close with a double quote and then include a double quote inside there, you'd have to escape it with a backspace. I'm sorry, backslash. Okay, you can always define your own function as well. All right, and we would define a function using the keyword def, okay, for define. And then you give it whatever function name you want to give it. You put in any arguments inside parentheses, and then you put in a colon, and this says, all right, the next lines, the indented lines, will be associated with the definition of this function. So here, we're going to define a function called shouting, and it's going to take in a phrase. And then that phrase, you know, with its strings, there is a method called dot upper, and it takes the, you know, whatever characters are in the string, and it makes everything uppercase. And then here we're going to append 3 exclamation points, okay? And that we're going to save to this object shout, and then we're going to return that object shout here. So here I'm going to define my function shouting, and then we'll call shouting on this string that says, hi, my name is Miles. And what it will do is we'll turn the strings into all uppercase, add some exclamation points. And indeed, it has the effect of feeling like we are shouting, right? Okay. If you put in something that's not a string, like the number 5 here, then we get an error because 5 is an integer, and integers don't have this method dot upper. Dot upper is a method that's associated only with string objects, right? So you can't say, what is the uppercase of the integer 5? Okay. But we can convert that integer 5 into a string. And so it has no problem saying, okay, let's just take that number 5, put quotes around it, and now it's a string. And now this string has an upper method, and so you can do uppercase. Now there's no actual uppercase 5, but it's not, at least it's not going to produce an error here. And so here we're going to redefine the function shouting, and all we're going to do is we're going to take whatever is in phrase, and we're going to wrap phrase with this function string, okay, str, around phrase. And what that does is it takes whatever input is coming in, integers, floating point numbers, strings, whatever, and it's going to basically convert to a string, and it unlocks basically the methods that are associated with string type objects. Okay, and so now we could say, take the number 5 and turn it into a shout. And it is interesting that just the inclusion of 3 exclamation points after the number 5 suddenly feels like somebody's like very excited about the answer is 5, right? Like, how many, whatever, do you something? 5, okay, right. Returning a value. So here, you know, we have this at the very bottom. We did return, shout, return, whatever this object is. So if you want the function to return a value, you have to make this, you have to use the keyword return, okay? And you can take that, and whatever object gets returned, you can then assign it to another object. So here we're going to do shouting on high, and that's going to be our greeting. So this is a very enthusiastic greeting. And so if I say, hey, what is greeting? This is going to be a string that says hi, all right? And that's what we have there, okay? If you do not use the keyword return, right? So this is different from R. In R, whatever that last line is, that's going to be the thing that's get returned. Whereas in Python, you have to use that keyword return. If you don't use the keyword return, then the function will return a none. So here I've got quiet on the phrase, and basically we're just going to take the phrase, make it lowercase. We're storing it as SHH, and here I have SHH at the bottom, but this isn't gonna return anything. So if I say whisper equals quiet on the hello here, and then I ask, what is whisper? What this function returns is a none, okay? And so when I ask, what is whisper, and I execute it, nothing actually comes out, right? So that's kind of the default. When you kind of say, hey, what is none? The default is not for anything to, so you can say, hey, what is, and I want you to actually print out what whisper is. Okay, when you print whisper, it says, oh, that's actually a none, okay? And then if you ask, what is the type on a none? None is its own type. It's the none type, which is basically like a null object. So we don't call them null in Python, we call them none, but it's the same kind of concept. It's used for things that do not exist. So it's, yeah, how do you express something that doesn't exist? We use a none here. Okay, let me go ahead and give you your first view quiz answer, which today is the letter B. B as in bear is your first view quiz answer. B as in bear. Functions can return multiple values. Multiple values get gathered together in what's called the tuple, all right? We will discuss tuples in a future lecture. Tuples are important. They are like a list in that they are ordered structures. Unlike a list, tuples themselves cannot be directly modified. You can always define a new tuple, but you can't take an existing tuple and modify it. But all of that we'll discuss in a future lecture. Basically, right now, we can just use this structure, the tuple, to return multiple values. So here we're going to create a function called powers of. It's going to take a number into as an argument, and we are going to define square, which will be number raised to the second power, and we'll define cube as number raised to the third power. And what it will return is it's going to return the three values: number itself, the square, and the cube. And these three, being separated by commas here, means this function is going to return all three values as a tuple. So I define this function, powers of. I'm going to execute powers of applied to the number 3, the integer 3, and it returns a tuple, 3, which is the number, 9, and 27, the square and the cube. One of the very nice features of Python is it has this thing called tuple unpacking. So here we're returning these three values in this tuple of length 3, and we can unpack them into 3 separate objects. So here I can take powers of 3, and we know powers of 3 returns this tuple 3, 9, 27, and I could unpack them into the 3 objects and give these values, these separate values here, or objects here, and store them in object X, object Y, object Z. So here I have basically a tuple of names, X, Y, and Z, and we're going to unpack this tuple, 3, 9, 27, powers of 3 returns the tuple 3, 9, 27, and that gonna get unpacked. So X is gonna get the value 3, 9 will get Y will get the value 9, and Z will get the value 27. So here I can say print X, and it says that's 3, print Y and Z, and we have 9 and 27. On the other hand, if you say, hey, powers of 4, and you assign it just to one object, J, then J will be the entire tuple, basically like this immutable list of 3 values. So J itself is the tuple with three separate values. There's 3 separate objects in there, 4, 16, and 64, all gathered together into this single tuple here. If you have this object J with multiple values in it, you can reference any of the elements in there using the square bracket notation to reference things. Python uses 0 index, so the very first element is at index position 0. So J square bracket 0 will be the number 4. And J square bracket 2 will be the third position, 64. Okay, so that's one of the things you got to kind of get used to. Python being 0 indexed versus if you, all of you took stats 20 and stats and R is, index position starts at 1. So there's just things you got to get used to, right? Switching from one language to another. But I think that's one of the easier things to keep in mind. It's just by habit, it's easy to make these mistakes, okay? Now, when you do tuple unpacking, you have to have, like, and if you want to unpack this thing, which is a tuple of length 3, you have to give it 3 names. So if I try to unpack, say, powers of 5 into 2 objects, it's going to say, I can't do this, okay? The number of elements to be unpacked must match the number of values that can be assigned. And so if you do this, it's going to say too many values unpack, right? So it says GH is equal to powers of 5. So it's expecting 2 values to be unpacked. And it's saying, I got 3 values in powers of 5. So you get an error. So either you store the entire tuple as 1, or you have enough things to store all of these things. When writing a function, it's important to keep in mind the way the code is read. And so basically, the flow of execution, I think it makes sense, but then I think it's easy to get some of these things mixed up, right? Execution always begins at the first statement, and then they run one statement at a time from top to bottom. When you define a function, the function itself is not executed at the time it is defined, okay? So the statements inside the function just go into a definition, but they don't actually get executed until you call it, right? So it's kind of like, I'm gonna build this contraption over here, and you don't actually know if it works until you actually say execute, okay? Try out this contraption, try out this function. So, and then a function call is basically like a little detour in the flow of execution. Instead of going to the next statement, it's gonna jump to whatever that function definition is, and it's gonna run the lines of code inside that function definition. So here is a very silly function. It's gonna call print twice, all right? And we gave it just this weird argument name of Bruce, okay? And this is because this is based off of the textbook Think Python, and the author of the textbook is a fan of Monty Python, you know, this kind of British sketch comedy thing. So anyway, we call print twice, and basically this function says we're going to just take whatever argument you put in there, Bruce, and we're going to print it, and then we're going to print it again. So if I call print twice on spam, spam is this running joke in the Monty Python thing, and so it will print out spam twice, okay? Here I'm going to say, all right, let's do some math. We'll take sine on pi halves, okay? And if I do that, you know, pi over 2 sine of that is 1.0, and it prints 1.0 twice. What do I get here? Spam times 2 is going to be spam, spam. And then if I print twice here, we get spam, spam, and then it prints it again, spam, spam. Okay, what do you think is going to happen here? Print twice spam. So whenever you see like functions nested inside other functions, you start at the innermost one and you work your way out, okay? So we'll look at print twice spam, and what that will do is it'll print spam twice, and then, and that's what we see here, and what happens after that, it prints none, none, okay? Because the innermost one prints spam twice, as we would expect, but then what does print twice spam return? This function by itself doesn't return anything. This function print twice returns a none. So now we're basically saying print twice the none. This inner function returns a none. So now I'm basically calling print twice a none. So it's going to print spam, spam, and then none, none, right? I want to make sure we're okay with the execution here. Print twice gives me spam, spam for the inner function, and then the outer function prints out none, none. Okay, this is the dumbest function, but we're going to call it stuff, and it takes in 3 arguments, A, B, and C, and then what it will do is it will print A, B, and C. Okay, obviously we would never define a function like this. We would just call print, but this will give us a sense of how default arguments work, okay? So if I don't have any default arguments, I can, you know, whenever I call it, I have to make sure all of the arguments that are going to be used in the function are provided. So I call stuff with arguments 1, 2, 3. 1 goes to A, 2 goes to B, 3 goes to C, and it prints out A, B, C, which is 1, 2, 3. Now, if I call stuff 1, 2, then it says, well, I don't have anything for C, and it says, I get an error. So, you know, one thing, again, well, as you're writing like your own little functions in Python and you run into errors, a lot of times the errors in Python are helpful. Now, I have to caveat this and say later, as you start working with functions and libraries and these packages and stuff, then your functions start to get more and more cryptic because you know, like when you do pandas and you make a mistake, then it will complain about the code inside the pandas library and you have no idea what that code is doing. But a lot of times, you know, it's important that you learn to be able to read error messages and understand what's happening here. So it says it's a type error, and the type error is that stuff, which is this function that we're calling, is missing one required positional argument, the letter C, okay, or not the letter C, argument C. And we can see, oh yeah, you know, stuff is expecting A, B, and C, and we really only provided values for A and B. So we can fix that by either providing a third argument, or we will define a function with default values. So here's another function called junk. And here we have 3 arguments, A, B, and C, but they all come with default values. A gets the default value 1, B gets the default value 2, and C gets the default value 3. And so now I can call this function with no arguments, and it will use the default. If I provide a single argument, it will assume it's the first argument. So here, 4 will go into A, and it will use the defaults for B and C. Here I can say B is equal to 4, and then B will get the value 4, and it will use defaults for A and C. You can still provide all 3 arguments, 5, 10, and 0. And A will get 5, B will get 10, and C will get 0. If you do want to assign things, then you can't do positional things followed by assignments. So if you do junk 5, then as Python is reading this, it reads left to right, and it tries to execute each of these things. So it says, okay, we're calling the junk function. Junk has A, B, and C. Oh, we're getting a 5 here. I'm going to assume 5 is the first thing, so it assigns 5 to A. And then it goes on, and then it says A equals 10, and now Python goes, oh no, I already gave the value 5 to A. What am I supposed to do? So it errors out, okay? Right, it says, I got multiple values for argument A. It took 5 and it assigned it to A, and then it got, oh, A is 10, and now it panics and it doesn't know what to do, okay? So that's fine. If you, that's just what happens here. If you say, all right, C is 5 and A is 10 and B is 0, it has no problem. It can do that, no problem, okay? So this is just how Python aligns and matches things. This is a little bit different from the behavior in R. I don't know if you've tried to write a function in R and execute it this way. R will try to like do all of the assigned things first, and then whatever's left, it goes positionally and stuff. So just a little bit of kind of like a design difference in the languages. I think this also makes sense as far as like why this breaks, but it breaks. I think that's it. Okay, let me give you your second view quiz answer. Today's second answer is the letter B. B as in bear. B as in bear. Okay. Here, we're going to define 2 functions, and we will look at kind of the variables inside a function, and just keep in mind that when you have variables inside of a function, those variables only exist inside the function. They are known as local variables, right? So they only exist within the scope of the function and not like the broader environment. So here we've got print twice, and we're going to take in the argument Bruce, and we're going to print it out. And then here's another function called cat twice, and it's going to take 2 arguments called part 1 and part 2, and it's going to just kind of paste them together. It's going to do part 1 plus a space plus part 2. which, you know, if these are strings, it just kind of glues everything together. And that's going to be return cat here. And then we're going to print twice the resulting object cat. Okay, so we're going to call print twice over here. Okay, so if we have line 1, which is bitty bitty, and line 2, which is bomb bomb, so this is classic song, okay? We'll call cat twice, line 1, line 2. So what is cat twice going to do? It is going to paste bitty bitty and bomb bomb together, and then it's going to print twice that result. Okay, so so it does exactly. I think this is what we expected, right? So when cat twice terminates, one thing to keep in mind though is that once this function finishes running, all of these values inside here just like they cease to exist. They only existed inside this function as it was running, and they don't exist outside the kind of global environment. So if I ask cat, it says that thing's not defined. If I ask about Bruce, it says that thing's not defined. These things only exist inside the functions while those functions themselves are running. If you do encounter an error, Python will print the offending line. If the offending line is a function, it prints out the contents of the function and the offending line inside there. And it continues doing this until it kind of reaches the topmost frame. The topmost frame is double_main, which is the top level scripted environment. So let's try doing this. Here, I changed the definition of print twice to Bruce, and inside here, rather than saying print Bruce, I'm saying print cat. Now this is going to error out because inside this definition of print twice, no object cat has been defined. And so it's going to kind of search the global environment for cat, and it's not going to find anything. So even though cat exists over here inside the cat twice function, it doesn't exist when print twice Bruce gets called. So if I run this, I get this, and you can kind of read through the traceback, right? It says, these were the lines. We called line 1, bitty bitty, line 2, bomb bomb, and cat twice was called, and this thing returned an error. What happened when I tried calling cat twice? Okay, well, when I executed cat twice, the code running there was we pasted together cat is equal to part 1 plus part 2. That didn't have an issue, but the line 7 here, print underscore twice cat, this is the line that produced an error. All right, and so what is this function that's running? So it runs this, and inside print twice, it uses argument Bruce, and then this line, this first line, print cat. This is the line that causes the error. Cat is not defined, okay? And so I kind of copied and pasted the output here, and it says, yeah, you know, these are the things that cause the errors. So cat is not defined, and it says, yeah, inside this function, you're trying to call on something cat, and you realize, oh yeah, this thing wasn't defined. So this is just it's a very, very simple thing, and I think we would be able to kind of read through this code and identify the mistake. But a lot of times these tracebacks, where it kind of lists off all of this output, will help you identify where something went wrong, okay? So again, my encouragement is as you code, as you write code and make errors, which is a vital and just part of the experience, right? Nothing works, or few things work the very first time. It's going to be important to be able to read through that error and understand, and at least get clues as far as where you're supposed to go to solve the problem. All right, so let's try this, okay? So here, I haven't changed the definition of print twice. I haven't changed the definition of cat twice, but one thing that I do have is that cat is defined in the global environment as something else entirely. And so when I execute this, when I do cat twice, line 1, line 2, you know, it does paste bitty bitty bomb bomb together inside this function cat twice, but then when it executes print twice cat, here, you know, Bruce gets the argument, Bruce has the value of the string bitty bitty bomb bomb, but then inside there, it's saying print cat. It doesn't see cat inside this local scope, so it searches kind of the global environment. It does find it. It does find something else entirely there, and it's going to print that twice. So no error here, but it's probably, it might not be what we expected, right? If we were expecting it to print bitty bitty bomb bomb, it's not going to print that. It prints out this other line that says something else entirely. So, so sometimes that's a thing, right? Perhaps more nefarious than getting an error message is code that runs but gives you not what you're expecting. And those are often harder to figure out because you're not actually encountering errors, you're just getting something different. And that requires you to kind of start tracing back the elements and the arguments themselves. And one of the kind of the old-fashioned and perhaps not the most efficient, but it's also just kind of one of the simplest debugging methods out there is just as you're writing your function, you just put in little print statements that says, this is the value of the variable at this moment in time, and it outputs that. And you can kind of verify, is this what I'm expecting it to do, right? And that's, again, that's not, you know, you have much fancier methods of using a debugger and all of these things where you can explore these things. But as far as just like a quick little check, it's just kind of like looking and seeing if what's happening inside the function is doing what you have. Okay. IPython has a few nice little commands that we can do to kind of see like what's inside the global environment. So we have %who, and this is all of the different objects that have names and have values assigned with them. Okay. If you want to know the details of this, you can do %whos, and it tells you like, okay, these are the names, cat twice, greeting, all of these things, and it tells you what kind of type of this thing, and then as well as the value of these things at this moment in time. And then you can also, if you want to reference any of these things, you can also get it back as a list. So here you can just print out the names. You can also get it as a list, and then with the list, you can kind of square bracket 0. And no, it doesn't like that. Okay. But you have a list, and I think you can save this as an object and then reference things there. Okay. We have assignment operations. Those, again, affect only what's inside the function, and they don't interact outside the function. So here I'm going to define, assign the value 5 to the name x. So in the global environment, x takes on the value 5. We are going to create a function called alterx. And all we're going to do is we're going to add 1 to x and store it back to x. And we're going to return that new value, right? So here, if I say, all right, take x, which currently has the value 5, and if I call alter x here, it's going to return the value 6, took 5, added 1, and returns that. But does the value x in the global environment actually change? It does not. The value x in the global environment still remains the number 5, right? Alter x here actually isn't altering x at all. All it is doing is it is taking x, adding 1 to it, and returning that value. So alter underscore x is not really the appropriate name to use here, okay? If you do want your function to actually change values in the global environment, you can use the keyword global. So here we're going to create a function called alter global x, and then we're going to say global x, which basically is going to take the value inside the global environment. It's going to take the value x, and it's going to say interact with that. Now we're going to add 1 to it and return that. So here I'm going to assign 5 to x. I say alter global x, and then we get back 6. And then if I ask what happens to x in the global environment, it has changed. The value in the global environment has changed to 6. This is a powerful but also dangerous keyword. Okay. Anytime you are changing things in the global environment, you have to tread very carefully. Just because debugging what is happening gets really hard, because now now you have to know exactly what your functions are doing to be able to understand why is my X now the value 6? Okay, and reading through your code, if you don't remember what the definition is of each of these functions and know which functions are actually manipulating values in the global environment, it can get really hard. It can get really hard. Okay. If you do kind of ask to, for a value that doesn't exist inside its function scope, then Python is going to just automatically search higher scopes until it finds it. So here we're going to just create this silly function called search for X, and the function just says print X and return X, but we didn't actually define X inside the thing. So it's going to search inside the local scope. It's not going to find anything. So it goes to the higher scope and it finds 6 in the global environment, and it returns that. It prints 6 out and it returns 6. So how does scope work, right? So scope, Python always kind of works in this order, right? It always starts off with the local scope inside the function body. And if it doesn't find that, it goes into any kind of enclosing scope. So if you have a function nested inside of another function, then the non-local scope or the enclosing scope is basically the outer function. And it keeps doing this until it reaches the top level, the global scope, okay? There's also a built-in scope. This is kind of just all of like the keywords, right? When you define a loop and you use for, it's not like you had to define somewhere what for is or anything like that. All of those keywords and stuff exist in the built-in scope of Python. Okay, so here are just some simple examples, and you can kind of work through them. We're probably going to run out of time here in class, but here I'm going to define X, Y, and Z to get the values 1, 1, and 1. I'm going to define a function. Inside this function f, we're going to change the value of y to 2. We're going to assign the value 2 to y inside the local scope of f, and we're going to return X, Y, and Z. So when it tries to return X, Y, and Z, it won't find X in the local scope, but it finds it in the global. It finds Y in the local scope, which has 2, and it finds Z not in the local scope, but in the global. So it's going to return 1, 2, 1. Okay. But do any of the values in the global environment change? No. So what we're going to see is 1, 2, 1. F is going to print out 1, 2, 1. X, Y, Z is going to print out 1, 1, 1. So that's what we see. We get back the tuple 1, 2, 1 for F. And then in the global environment, we still get 1, 1, 1. Okay. See if you can figure this one out. We have F, which is Y and 2. Inside F, we define G. G is going to assign 3 to the value Z. G returns X, Y, Z. F itself returns what G gets executed. So we're going to call print F. What are we going to get? Are we going to get 1, 2, 1, 1, 2, 3, or 1, 1, 1? Okay, well, this is, you can do kernel, clear all outputs and see what you get. But here we're going to get 1, 2, 3. None of the values in the global environment get modified, and they all remain 1, 1, 1, right? And as you kind of work through these, you can kind of see how much you understand here. And I try to put in a little explanation of what's going on there. Okay, here I got X, Y, Z is 1, 1, 1. Let me go ahead and give you your last view quiz answer. Last view quiz answer is the letter E. So question 3 is E. Okay. So G, inside G, we have Z equal to 3. Inside F, we're going to assign 2 to Y, and we're going to return G. Okay, so when I print F here, what happens? Am I going to get 1, 2, 3, 1, 2, 1, 1, 1, 3, 1, 1, 1? What do we get? We're going to get 1, 1, 3, 1, 1, 3, because here, when we call F, it returns G. Okay, it's going to execute this. When we execute G, whatever happened here with Y equal 2, that doesn't get transferred over here. These are separate scopes. G is not inside of F, right? G is inside the global environment. So when it looks for y over here and it doesn't find it here, it searches the higher scope and it's going to find 1 in the global environment. And again, nothing in the global environment gets modified when we do this. All right, here with global, now we're going to actually change stuff in the global environment. G is defined inside of F. So when it searches for Y inside here, it's going to search the enclosing scope and it's going to get the value 2. Here, when we say global Z, it's going to modify values in the global environment. So when I execute this, it's going to return 1, 2, and 3. And when I print X, Y, and Z, X will remain 1, Y remains 1, but Z has been modified because of global Z here. This is going to modify Z to the value 3. So we're going to get 1, 2, 3, and 1, 1, 3. Okay. This is a little bit different. G is going to return X, Y, and Z. It's going to search for Y in the global environment. Okay. And it's going to get Z locally for 3. Here, when we execute F, though, when we execute F, it will change 2 to Y. So notice, first I'm going to say print G. Print G here is going to go 1, 1, and then it's going to get 3 because it's looking for X and Y. X and Y in the global environment are all 1. So this is where we're going to get 1, 1, and 3. But now if I say print F, it's going to execute F. When it executes F, it's going to change the value of Y to 2 in the global environment. Inside F, we call G. When it executes G, now it assigns 3 to Z. It searches for X in the global, which is 1. It searches for Y in the global, which when after executing F is now 2. And then Z is going to get the local value of 3. So here, F is going to print out 1, 2, 3. And then here, X, Y, Z is going to print out 1, 2, and 1. Okay. So I know I'm going through all of this quickly, but you know, I encourage you to kind of clear all the outputs and see if you can kind of figure out what each of these code chunks are going to return. Okay. Similarly, so over here, if you say global something and something doesn't exist in the global environment, it will define it. It's like the air conditioner suddenly turned on. I thought we were turning off the air conditionings. I don't know, right? We all got that email. All right. Well, anyway, there's a few more lines of code. We're out of time here. There is a argument called non-local, similar to global, but it's for enclosing scopes. So you know, everything is local unless you define otherwise. So if you want to define modify something within the non-local scope, but not in the global scope, there is a keyword called non-local. It works in a very similar fashion to the keyword global. Okay, we'll go ahead and end here. Look at the rest of the notes to make sure you understand scoping in Python. Okay, I'll end here. We'll see you guys on Wednesday.